x be seen in this original function? Think about that. Don't give it up. Don't spoil the surprise. Keep it to yourself and think you know already. Let people think about it. How about this example? Where would I have gotten 15x to the fourth from the original problem? 15x to the fourth from here. 4x from here. Did you figure it out? 4x is simply the derivative of the inside function. Okay, the derivative of 2x squared minus 3 is 4x. The second example, 15x to the fourth happens to be the derivative of this inside function. Okay, so this leads us to a new rule, that we can kind of do it like our intuition tells us to do it, but we have to make an adjustment, which is we have to multiply by the derivative of the inside function. Okay, that's what the chain rule says. So let's write that down as a formula. And you'll see why in a little while, maybe not today, but in the future, why it's called the chain rule, because sometimes this rule is used repetitively, kind of like chain link. So the chain rule goes like this. If you want to take the derivative of a function within another function, f of g of x, where g is the inside function, f is the outside function. What we do is you take the derivative of the outside function, which is f prime, evaluate it at the inside function. Okay, so you just take the derivative of the outermost function, but then your adjustment is that you have to multiply that by the derivative of the inside function. Okay, so that's the chain rule. Now, another form of the chain rule that you'll see in a lot of other resources, including your book sometimes, if you let u equal g of x, and if you let y equal f of x, you will see this formula. dy dx equals dy du times du dx. So to find dy dx, which is the derivative, we would take the derivative of y with respect to u, which is the inside function. So use the g of x, times by the derivative of the inside function with respect to x. So it's kind of a funky form, but it means the exact same thing. Okay. I like this one the best. But basically, you just have to understand this procedure, not so much memorizing the formula. Okay, so let's go back and do an example. Here's the problem that I started off class with. What's the derivative of sine 2x? And we said that maybe the derivative is just going to be cosine 2x. We have to use the chain rule. Here, the inside function is 2x. So what we're going to do is we're going to take the derivative of the outside function. Now, the outside function, I just think about this as sine of something. The derivative of sine something is cosine something. So that's where you start. And then you multiply by the derivative of the inside. Here, the derivative of the inside is 2. So the actual derivative is 2 cosine 2x. Okay, just a little bit different than what you might have thought. Okay, the other example that I showed you earlier was what's the derivative of sine x squared? Well, again, this is a composition function. In this problem, x squared is the inside function. So to differentiate this, we start with the outside. Derivative of sine something is cosine of that something. But then the adjustment is to multiply by the derivative of the inside function, which is 2x. So the derivative here would be 2x times the cosine of x squared. Okay. And notice these are both examples where we couldn't have simplified like we did in those polynomial examples I showed earlier. There's nothing you can do to simplify these two functions or put them in a different form. So we actually have to use the chain rule on these two examples. But it's pretty easy once you get the hang of it. Okay? So So I want you to see if you can do a couple examples here. Try these problems. Okay, somebody wake up Annie. She's falling asleep again over there. Hey, Annie, wake up. Yeah, wake up. Yeah, you. Come on, you're setting a bad example for everybody. And even Burry's paying attention. Come on. All right. I'd like you guys to try these examples using the chain rule. See if you can do them. So sine of 3x squared plus 4x. And second one. X minus x to the sixth. So let's see if you can take a few minutes, maybe about 5 minutes, find the derivative of each of these, check the answers with the people around you. And so if I can get the substitute to pause the video for a little bit here, I'll come back in a little bit with the solutions. Good luck. Okay, let's see how you did. So the way you want to think about these problems is the first thing you need to do is look at the problem and decide what is it that's outside and what's inside. And sometimes it's obvious, like in these examples, they both have a set of parentheses, which is in a way explicitly stating what is the inside function. So in this particular problem, that's the inside function. In this particular problem, that's the inside function. It's the stuff that's in the parentheses. There will be examples that aren't so clear later on, but for right now, that's what you can think about. Okay. So here's how I use the chain rule. The outside function here is sine. So we think about this as it's the sine of something. So to differentiate that, the derivative of sine is cosine. So we just say it's cosine of that something. And then the adjustment is that I'm then going to multiply by the derivative of the inside function, which is going to be more than one term, so I'm going to put the derivative of the inside function in parentheses. So the derivative of the inside function, 6x plus 4. Okay. And probably, there's not much to do to simplify that one. I would probably write that in front. But, that's not a big deal. You can leave it at the end if you want to. And that's pretty much all we can do with that. Okay, so that's the derivative of that first example. Okay, the second example, the outside function now is sixth power. It's like something to the sixth. So the way you think about this is the derivative of something to the sixth is 6 times that something to the fifth. That's normal power rule, multiplied by the derivative of the inside function. The derivative of the inside function is going to be, hold it. I should have had, that's okay. 4x minus x. I meant to do 4x squared minus x. Sorry about that. It doesn't matter though. The derivative of the inside, since this would simplify to 3x, the derivative would be 3. So multiplying the 3 by the 6 would give you 18 times 4x minus x to the fifth, which obviously is just 3x to the fifth. Sorry, I meant to make that a little bit more complicated. But oh well, we won't go back and redo it. Okay, now let's look at some more challenging situations. Let's say the function I'm differentiating is square root of 2x plus 3. Now there's no parentheses here, so you still have to look at the problem and identify what's inside and what's outside. And again, it's pretty clear. The outside function is the square root. The inside function is the 2x plus 3. Okay? So the way we're going to solve this is we have to take the derivative of the outside function to start. So remember that the derivative of the square root of something, we had a formula for that. It was 1 over 2 square root something. Okay. We derived that in class with the limit definition. So I'm just going to use that rule now. The derivative is going to be 1 over 2 square root something, which is 1 over 2 square root 2x plus 3.